Today's further maths question is from Edexcel 2020. The topic is calculus methods, in particular the use of L'Hopital's rule to find a limit. So the question is from Further Pure 1. It is a question 1 and is a fairly accessible start to the paper. It's a show that question with an answer given, so we must make sure we make all the steps clear to get to that answer. So a reminder of L'Hopital's rule: we're finding the limit of a quotient fx over gx as x goes towards a, and we're dealing with a situation where fa and ga are both 0, and L'Hopital's rule says that the limit will equal f dashed a over g dashed a, assuming of course that both of those exist and are finite. So here we have f of x is e to the sine x take cos of 3x take e, and f of pi over 2 is therefore e to the sine pi over 2 minus cos of 3 pi over 2 take e, which is naught. And on the bottom, g of pi over 2 will be tan of 2 pi over 2 tan of pi, which is naught. So a situation where L'Hopital's rule is to be used. We need to differentiate using the chain rule, so we differentiate the numerator to get cos x e to the sine x, add 3 sine of 3x plus naught, and we differentiate the denominator, g dashed of x equals 2 sec squared of 2x. So the limit we want is going to be f dashed of pi over 2 divided by g dashed of pi over 2. It's a show that question, so make sure we show the details of pi over 2 being substituted into the correct expressions. So cos of pi over 2 e to the sine pi over 2, add 3 sine 3 pi over 2 divided by 2 sec squared of pi, which is 0 take 3 over 2, which is minus 3 over 2 as required. An accessible question. I think the main problems here would be, firstly, not differentiating correctly, and secondly, not showing enough details, particularly of substituting pi over 2 into the correct expression. The examiners here condoned not showing that f of pi over 2 equals g of pi over 2 equals naught. Condone means, strictly speaking, you should do something, but the examiners won't deduct marks, and I suspect it's because they did say use L'Hopital's rule, so that is perhaps taken as given. So a nice accessible question. L'Hopital's rule is not examined every year. It's one of those topics that comes up every so often, so this question is worth examining, looking at as an example of what may be asked. I'm David Forster. This is Gold Standard Maths.